All right, number 2. What is the pH of water? This goes to Ruben. Take a guess. We never leave an answer blank. Pick a number 1 through 14. What do you think water is? Thank you, Ruben. pH of water is 7. It's neutral. It's right in the middle of that scale from 0 to 14. We talked about this yesterday with our lab. Number 3, which of these pictures represents a molecule? This goes to Brianna. It is C. Notice that there is bonded chemicals. The green spheres and the purple spheres are bonded together. So that makes them molecule. Quit talking. All right, number 4. Which of these pictures represents an element? This goes to Noah.
B.
It is B. Notice that there are 2 spheres bonded together, but they are the same sphere. So that would be like an O2 or an N2 or an H2 molecule. It's just one element bonded together. Which one of these would be an atom? It would be A. Just one sphere by itself, one single atom. What would D represent? Mixture? Yes, it would be a mixture. Very good. Oh no, I want it bigger than that. 200. There we go. So look at D. We have molecules, we have elements, and we have atoms all in the same container, but they are not bonded together. Except for the molecules, nothing else is bonded together. So it's basically like putting different colored marbles in a jar. It's a mixture. Nothing's bonded together, just mixed together. Very good. All right, make sure your name's on that. You're going to go ahead and turn that in because this is the last one that we will do on paper this week. You have one person from your group turn them in. So not everybody has to be up at once. And then open up your notebook. We're going to be on page 22 if you're on the same schedule I am. That wasn't an invitation to talk. All you gotta do is turn papers in. Just hold on to it. Get the rubber band off your arm. It's gonna make it worse. Again, you should not be talking. If you guys continue to be like this, it's going to be time to start thinking about assigned seats. And you're not going to like who I assign you with. So why don't you just calm down, do what you're supposed to do. Everybody should have their notebooks out. Page 22. It's been a while since we've added anything to this notebook. Title of this one is Chemical Formulas and Equations. This gets a little bit mathy, so just hang in there. So we've talked about elements, we've talked about molecules, we've talked about atoms, and we've talked about chemical and physical reactions. Bless you. Now we're going to talk about how do we calculate reactions? How do we write it out? How do we show something that's occurred when we're reporting, when it's on paper? I gave you a warm-up a couple weeks ago that had you counting atoms and elements. So, and most of you actually seem to get it, even without really knowing the procedures. That's good. So you're ahead of the game. Using Cornell notes, our question on the left is, how do we know how many atoms or elements are in a chemical formula? How do we count that? This is a chemical formula. All a chemical formula is what the molecule or element is, written on paper. Not drawing, but it's actual numbers and letters that shows you how many elements is in a formula and how many atoms. Bless you. There are a few parts to this. Coefficient, there's your math term. The coefficient tells us how many molecules there are. It doesn't tell us how many individual atoms necessarily, but if you have a whole H2 molecule and there's a coefficient in front of it, that means there's more than one. We don't see the number 1 as a coefficient. We just would see H2O. If we see just H2O, we know there's just one water molecule. However, when we put a coefficient in front of it, like 2, that tells us how many molecules there are. The little number, the subscript. If you're doing 2 squared, that's a superscript. When the number falls below, that's a subscript. It tells us how many of the elements there are to the left of that number. So if I didn't have this 2 here, I just had H2O. How many hydrogens do I have? How many hydrogens? 2. It tells us how many of that element is there. I'm gonna get mad. Those are the only 2 numbers you will see in a chemical formula. They don't have superscripts like in math. We don't have H2O squared. The way we count atoms and elements is by the distributive property. First, I list how many of each element I have. So I have hydrogen and oxygen. That's it, right? So I'm just going to put hydrogen and oxygen. I'm going to list my elements first. Then I would do the distributive property. When you have a coefficient, that's like putting a parentheses around the molecule. That's why I added little dots. It's invisible parentheses. So I have 2 of everything in the parentheses. You multiply. So 2 times 2 is 4. So I have 4 hydrogens. I only have 1 oxygen, so 2 times 1 is 2. I have 6 atoms altogether with 2 2 water molecules. 2 elements and 6 atoms. Does anybody not see how that works? It's not super hard. It can be really intimidating when you have a chemical equation. But for the most part, it's not that hard. The math of it is not that hard. It's just getting your answer may be a little intimidating when you see a bunch of letters mixed in with it. Because y'all with algebra, y'all freak out when you see a bunch of letters in something. The math part of this is easy. Shush. All right, I gave another example. 3C6H12O6. We know C6H12O6 is glucose. And because we have a coefficient of 3, that's telling me we have 3 molecules of glucose. So now I need to do my pretend parentheses and do the distributive property. I have 3 elements. I have carbon, I have hydrogen, and I have oxygen. So only 3 elements. Let's do multiplication. 3 times 6 is what? 18. I feel like a math teacher. 3 times 6 is 18, so I have 18 carbons. 3 times 12 is what? 36, so I have 36 hydrogen. 3 times 6 is 18, so I have 18 oxygen. You add it all together, you have 72 atoms total when you have 3 glucose molecules. That's all there is to it. Somebody's having a really good time. They're definitely more awake than we are. All right. Cornell notes, we put a word on the left. That means it's a word that you really need to know, like a vocabulary word. Yes. Chemical equations. It's a way to write out how 2 or more substances react. We did the physical reactions yesterday. We physically mixed stuff together. It created a chemical reaction. We put the hands-on yesterday. Now we're going to talk about how to write it out. How we would report what the reaction was. And we would do that through writing a chemical equation, like a math equation. Oh, yeah, a boo-boo. You don't want to write down my boo-boo. I'll move up if you want. I got 3 seats up front. Or the table, or grab a pillow, sit on the floor. If you remember, whenever I wrote up the chemical equation for our calcium chloride reaction that we did last week, I told you that arrow does not mean equals. That's a math thing. In science, the arrow means yields, or produces, or makes. In an equation, there's 2 different sides. There's the reactant side and the product side. The reactants are like the ingredients They're what's causing the reaction. So in our calcium chloride and water experiment, the reactants were calcium chloride and water. It's on the left side of the arrow. It's the ingredients that we mix together to cause the reaction. Arrow indicates a chemical change. And then what is made or formed from the reaction is called a product, or the products. It is what is produced. So in our calcium chloride reaction, the reactants were calcium chloride and water. It produced calcium hydroxide and hydrochloric acid. That's what was made. If you remember that products are what is made or produced, then you remember which one is the reactant. Does everybody have this part up here down? They may not have that. This last bit. This is an example. This should look pretty familiar. This is the chemical equation for photosynthesis. 6 CO2, so 6 carbon dioxide molecules, plus 6 water molecules, add a little sunlight, yields 6 oxygen molecules and 1 glucose molecule. The reactants are carbon dioxide, water, and sunlight. That's the ingredients for photosynthesis. The products, or what is made in photosynthesis, is oxygen, which we need, and glucose, which is what the plants need. For the test, quizzes, benchmarks, all that, what you need to know is to be able to look at a chemical formula and they say, list the reactants of the equation, list the products of the equation. You need to be able to do that. If you just practice and study, it comes real quickly. Not that hard, you just gotta know it. After you're done copying the notes, you can put your notebook to the side. Mm-hmm. Is it bad to touch? They make jewelry out of titanium. I got titanium in my knee.
I meant like, wait, what? It's a titanium in the east.
Yeah, I had knee surgery. They put staples and a rod through my bone to hold my new tendon.
So,
I used to have pictures. I don't know if that's still there. Oh no, they put me under. It was like,
so if you get shot, they don't hurt.
no, it hurt. It's not hurt. It's not my whole knee. I just have titanium pins and rods. I still have skin and hurt. Make sure your name is on this worksheet. have been put into, what's that thing called? Power School. I still have a few more grades added, including your stations lab from last week. Your warm-ups will also go in this week. And then the labs and worksheets we're doing this week will go in by the end of the week.
Ms. Thomas,
Yes, ma'am.
could you send Tyrone Mabry starters, please?
Sure.
Thank you.
Seriously. Hold on. Guidance. I'm gonna need more passes. Alright. We're gonna be doing a brain pop video and you're gonna be answering questions. I will not be going over this worksheet. When it's done, you will just be turning it in, so you need to pay attention. Oop, too many E's. Street.
Still trying to turn lead into gold? Hey, isn't this just food coloring? Dear Tim and Moby, what is the law of conservation of mass? And what happens if you break it? I love you, Marianne. Thanks. You can't actually break the law of conservation of mass. It's not that kind of law. In science, a law is a generalization about how the physical universe works. The law of conservation of mass basically means that substances can't be created or destroyed. Or, in the language of chemistry, the mass of the reactants in a chemical reaction always equals the mass of the products. Yeah, let's take a look at some of those terms. First of all, mass is the amount of matter a substance has. Unlike weight, which changes depending on how much gravity is present, mass stays the same no matter where you are. So, while you may have different weights on, say, the Earth and the Moon, your mass always stays the same. We're good? Okay, next. A chemical reaction is when two or more molecules interact to form different molecules. For example, hydrogen and oxygen react to form dihydrogen monoxide, or water. In that reaction, hydrogen and oxygen are the reactants, the substance that are around at the beginning of a chemical reaction. And the water is the product, or what's around after a chemical reaction takes place. The law of conservation of mass states that the mass of the reactants must equal the mass of the products. Well, I know it seems kind of obvious. Stuff can't just disappear or appear out of thin air. And before the law was actually written down, people had been proposing the idea for centuries. Probably the first person to propose the law in a scientific way was Mikhail Lomonosov in Russia in about 1748. But his work wasn't known outside of Russia until much later. In the 1780s, a French guy named Antoine Lavoisier came up with a more precise description of how the law works, so we usually think of him as its discoverer. Yeah, sure it's useful. If you only know part of the mass of the chemicals in a reaction, you can use the law of conservation of mass to figure out the rest. Let's say you have 4 grams of hydrogen and 32 grams of oxygen. By adding the masses of the reactants together, you can figure out the mass of the product, 36 grams of water. You can do it backwards too. Potassium oxide combines with water to form potassium hydroxide. So let's say you have 18 grams of water. How much potassium oxide do you need to get 112 grams of potassium hydroxide? Yep, you need 94 grams of potassium oxide. Yeah, you didn't use enough. It takes 250 grams of blue food coloring to turn lead into gold. Yeah, I'm joking.
You watch it one more time?
Yeah.
Alright, one more time, and that's it. That's only if you're not talking. I won't play it again. If you're talking, there's no point.
Still trying to turn lead into gold? Hey, isn't this just food coloring? Dear Tim and Moby, what is the law of conservation of mass? And what happens if you break it? I love you, Marianne. Thanks. You can't actually break the law of conservation of mass. It's not that kind of law. In science, a law is a generalization about how the physical universe works. The law of conservation of mass basically means that substances can't be created or destroyed. Or, in the language of chemistry, the mass of the reactants in a chemical reaction always equals the mass of the products. Yeah, let's take a look at some of those terms. First of all, mass is the amount of matter a substance has. Unlike weight, which changes depending on how much gravity is present, mass stays the same no matter where you are. So, although you may have different weights on, say, the Earth and the Moon, your mass always stays the same. We're good? Okay, next. A chemical reaction is when two or more molecules interact to form different molecules. For example, hydrogen and oxygen react to form dihydrogen monoxide, or water. In that reaction, hydrogen and oxygen are the reactants, the substance that are around at the beginning of a chemical reaction. And the water is the product, or what's around after a chemical reaction takes place. The law of conservation of mass states that the mass of the reactants must equal the mass of the products. Well, I know it seems kind of obvious. Stuff can't just disappear or appear out of thin air. And before the law was actually written down, people had been proposing the idea for centuries. Probably the first person to propose the law in a scientific way was Mikhail Lomonosov in Russia in about 1748. But his work wasn't known outside of Russia until much later. In the 1780s, a French guy named Antoine Lavoisier came up with a more precise description of how the law works, so we usually think of him as its discoverer. Yeah, sure it's useful. If you only know part of the mass of the chemicals in a reaction, you can use the law of conservation of mass to figure out the rest. Let's say you have 4 grams of hydrogen and 32 grams of oxygen. By adding the masses of the reactants together, you can figure out the mass of the product, 36 grams of water. You can do it backwards too. Potassium oxide combines with water to form potassium hydroxide. So let's say you have 18 grams of water. How much potassium oxide do you need to get 112 grams of potassium hydroxide? Yep, you need 94 grams of potassium oxide. Yeah, you didn't use enough. It takes 250 grams of blue food coloring to turn lead into gold. Yeah, I'm joking.
Alright, take a couple minutes to finish up, then turn it in. There should be no talking, this is what you know. All right, for the next thing we're gonna do is practice counting atoms and elements. I'm gonna be handing you out a worksheet. It has an example at the top, shows you the directions. You're gonna write out the elements and the number of atoms each element has. I do not want you to do the Superstar Challenge. I mean, you can do it if you want, but I'm not gonna grade it. So just worry about numbers 1 through 12, and when you're done, turn it in. While you're working on that, if you did an act of kindness yesterday or this morning, please take a moment to write it up on the first period bulletin. Also, sometime, come up here and sign the poster for our custodians, please. Thank you, sir. And if you have questions, please raise your hand. This is individual work, and it should not be too hard. This is very easy stuff. But if you get confused because this is new, just let me know. Brittany, we kind of have to make sure you get the notes from somebody that we took. Make sure you get all the notes. The whole thing. That way anybody else that didn't finish copying, y'all can get it too. Y'all don't have to work in your seats. If you want to go sit in the comfy chairs or on the floor with the pillow, you can. As long as you don't talk, that's fine. Be comfortable. Make sure you've signed the poster, and I'll see you fourth period. Nobody was signed yesterday. Nobody.
I was.
I did something nice.
Write it up fourth period.
I told my little
Sign
sister.
fourth period.
I
Fourth
know
period.
that.
Y'all, if you haven't signed the poster, I'll have it up fourth period.
Way better than you.
Aaliyah, if you need to put back up, you can. Merlin, if you need to lock, you can. And you can check before 8:20 tomorrow, okay?
That's why. Yes, Thomas knows spirit college.
You need to scale down your books.
Oh, whoopee. Oh, no, we're not doing it right
Did you study your vocab from last week?
So, like, moving.
On what?
The vocab from last week.
It's a new thing.
So you're ready for it? Did you take it yet?
Yeah, I took it.
Oh, okay.
I was here on the day we took it.
All right. Did you take the vocab quiz last week? Did you study for it?
Do?
You should get out your starter paper from yesterday. You're gonna be adding this to it. Shayla, be careful. I just dumped out some bleach over there, so don't put it on the clothes. Anybody had any acts of kindness? Please add it to the secretary's paper over there.
I hope Benji write his name. You get me a picture.
I can write it small so that.
You get me a picture.
I didn't do that.
You get me a picture. Yeah, you get me a picture.
Drop your books in the.
You gotta write it on the thing. Write it on the thing. Here. For random acts of kindness.
Gilbert Inch wasn't here.
What'd you do?
I carried it down Fortnite and got him a win.
What did I say? You all put that.
Yeah.
No, I did
I'm not
though.
right now. What Jaden do? Tell me what it says. He made dinner for his parents. Huh? He made dinner for his parents.
Those are doing their fourth year.
Write that down for you. Don't put your name. Babysit my parents.
I've been doing it.
Whoa. Look at that dog.
Right, every time you go up there, you say,
This way. That way.
there. Real quick, you carry it.
My dad's three.
Where you set it, Dawson? You sit at the front table this small.
Nope, all the way to the back.
Yeah, and I carry.
You weird. I'm just kidding, but 30. My dad's
What? Dawson. Dawson. What you say about my name?
I didn't say nothing. I said acid.
He was talking about this.
Stupid acid. I said
Yeah, but you don't be copied.
that's a lie.
No, acid is under 7.
Yeah, you see what game you?
What?
You do not have to draw the pictures, unless you just really want to. All you do is write down the question and your answer. We'll give you about 4 more minutes. And after we are done, we're gonna turn it in today, because it'll be the last official warm-up we have this week. Yep, so the direction.
Do we have to write Richard's pictures in the molecule?
I'm sorry, what?
Do we have to write number 3 and 4?
Yeah, just don't draw the pictures unless you just really want to. I'm not grading pictures. So you write them if you want.
There's a blue and a green. You're all transported.
All right, looks like a lot of people are done, so we can call people to answer.
What?
This is what you know. Not your neighbor. All right, couple announcements while people are finishing up. Reminders, project's due in 4 days. You've had several weeks, you got 4 more days. It's almost there.
I finished my wrong.
I'm done with my drawing.
You know, 10% of your grade, okay. Finish the 90 other percent, you're good to go. Quiz. I think is being moved to Tuesday, but right now it's still Friday, but don't quote me on it, but I think it's gonna be moved to Tuesday. Assume it's still Friday and hope it moves till Tuesday. That's what we'll do. Progress reports, nah, that's not y'all. Picture day Friday, remember SMOD. If you're not wearing SMOD, you can't take your picture, you can get a call home. You have to take a picture on makeup day. And remember, they're only gonna see you from here up anyway. It literally doesn't matter what you wear, because all they're gonna see is this. It doesn't matter. Seriously. Mm-hmm.